Welcome to the second module of this course, which is Sketcher. Sketcher is used for creating a 2D sketch. A 2D sketch is used for creating 3D models. So, if you want to create any 3D model, you have to create a 2D sketch. So, you have to be perfect in creating a 2D sketch so that you can create a perfect 3D solid model. Now let us move over to SolidWorks and start Sketcher module. When you open SolidWorks, this is the screen that you are going to get, and this is the welcome window that you are going to get. Here there are many things. We need to know about these three: part, assembly and drawing. So you can create a new part, a new assembly or a new drawing. We are going to work with parts. So we can click here and it will open up a new file. You can see. Suppose you are not getting that screen in your version of SolidWorks, or somebody might have deactivated it. Then let me close this file. Your screen will look something like this, and what you can do is just click on this new icon, or you can go to File, New, and you'll get this screen where you have options to create new SolidWorks document. You can create a new part, assembly or drawing. Click on part because we want to create a new part. Click on OK and a new file will open. We have already seen these are the ribbons that are present in SolidWorks. Here we will work with this sketch ribbon. You can see the sketch ribbon contains all the tools for creating a perfect sketch. First, what we need to do is we have to select a plane on which first what we are going to do is we are going to select a plane on which we are going to create a 2D sketch. Here we have this sketch icon. Click on sketch. As soon as you select sketch, you will be presented with these three planes. Now, as this is a 3D interface, so we have three planes: XY plane, YZ plane and ZX plane. And of course, it consists of three axes: X axis, Y axis and Z axis. Now, we can select any one plane because we'll talk about these planes in 3D later. In 2D, we just need a plane. So I'll select this front plane maybe, and you can see we have entered inside the Sketcher workbench. Here we are presented with this plane. In this all the tools that you have. This set of tools is for creating some geometries like line, circle, rectangle and so on. These tools are used for editing and multiplying those geometries. We will see them a bit later. In this lecture, we are going to see how to create lines using the line tool and visual tools. Let us click on this line. I'll click on line tool. For a line, what we want? We require a minimum of 2 points. So I'll click somewhere here. You can see the line has started. Now it wants the second point. I'll click somewhere here. You can see, maybe I'll click here. So wherever you click, you'll form a new line. So it is forming a chain of lines until you press the escape key to exit from the command. Let us press the escape key on the keyboard. I'll press on the escape key and you can see the line has disconnected. And we have created the first drawing. It's a set of lines. Let us do it again. Click on line tool. Click somewhere, maybe here. And I'll click here, here, here. Just go on creating points and it will generate lines. Press on the escape key to exit from the command and to disconnect the chain of lines. So this is how you can create lines. Next, let us see the visual tools. There are three types of visual tools. The first tool is pan, second is zoom, and the third tool is rotate. Let us first see the zoom tool. Use the middle mouse button, that is the scroll. Just rotate the scroll. You can see this is zoom and unzoom. This is not making the size of your object small. This is just taking the object far and bringing it back to you. So you can see the object far away and you can see the object near. So it's your wish. Now if you see, this is the coordinate system about which we have created these lines. If I want to just move these objects along with the coordinate system on the screen, then I can use the control button on the keyboard, just press and keep, and press the mouse middle button. Both buttons when you press and then move the mouse, you can see. This is called pan. So I can keep the object somewhere here and maybe I can create a set of lines somewhere here. Press on the escape key to exit from the command. You can see I can zoom and I can pan. Now there is another tool which is used in 3D, not in 2D, which is called as rotate. For rotating the object, you can just press the mouse middle button and move the mouse. You can see we can rotate the object. This option we are not going to use in 2D, but still, if by mistake you have done this, then how to get back to your normal view, that I am going to show. Here when you click, this is the view orientation tool. This is the various ways in which you can view your object. We'll see all these later, but for now, I want to show you this normal view. Click on this normal to icon and it will get back to your normal view of your plane on which you have created the object. So this is all about creating lines and the visual tools. Don't worry, we are going to practice lines and visual tools rigorously in the further lectures. In the next lecture, we are going to see the concept of degrees of freedom and how to constrain those degrees of freedom using various types of constraints. So, I'll see you in the next lecture. In the last lecture, we have created a line using the line tool. Now, we have not given any dimensions or any kind of relations with any other objects. In this lecture, we are going to see the concept of degrees of freedom in 2D and how to constrain those degrees of freedom by using various types of constraints. Let us start. This is the SolidWorks gateway. If I want to create a new file, we'll just click on this new file icon and we want to create a new part. Click on OK. And you can see we have opened a new file. We'll go to this sketch ribbon and here click on this sketch icon. As soon as you select the sketch icon, you will get these three planes. Let us select this plane. Now we are inside a sketch workbench and we are going to work on a 2D plane. Now let us create a line. I'll select this line icon and I'll click here and maybe here. Press on the escape key to exit from the command. Now this is a line. This line enjoys all the degrees of freedom that it can have in a 2D. Let us see what is a degree of freedom. I'll just hold this point. Click on the left mouse button. I'll press and hold and you can see this is a degrees of freedom. That is, this point moves wherever it likes. Even this point, it is moving wherever it likes. Each one of this is a degree of freedom. Translation along y-axis, translation along x-axis, rotation along z-axis. Each one of them is a degree of freedom. There are 6 degrees of freedom of an object. Translation along x-axis, translation along y-axis, translation along z-axis, and rotation about x-axis, rotation about z-axis, rotation about y-axis. Now these degrees of freedom need to be constrained. As we are now working in a 2D plane, so the 3D degrees of freedom, which are rotations and translation along z, will not affect. And here what we have to do is, we have to give along x-axis and along y-axis and the rotation along z-axis. These 3 degrees of freedom we have to give. Let us see what I am talking about. I'll select this and I'll delete. Now let us create a rectangle. During creation of the rectangle, I'll tell you how to constrain the degrees of freedom. Let us click on this line tool. I'll click here and I'll click here, maybe here and maybe somewhere here, and I'll click here. Press on the escape key to exit from the command. Here we have 4 lines which doesn't resemble like a rectangle, isn't it? If you want to create it as a rectangle, then we have to give some constraints, and during giving the constraints we will be restricting the degrees of freedom. Let us check what kind of degrees of freedom it has. You can see each and every part can move. Now our job is to fix those parts by giving constraints. There are 2 types of constraints. First is the geometrical constraints and second is the dimensional constraints. Geometrical constraints are something like perpendicularity, parallelism, concentricity, point on to point coincident, line and line coincident, and so on. We will see each one of them as we progress through the course. The second type of constraint is the dimensional constraint, which are something like radius, diameter, distance between 2 lines, distance between 2 points, length of a line, and so on. Here we are going to use both the types of constraint to restrict the degrees of freedom of this object. Let us start. First, what I am going to do is, this point and this point, I want to coincide. Let us click on this point. For multiple selection, press on the Control key and I will select this point. As soon as you select these 2 points, you will get a dialog box here, which displays all the relations that you can give with respect to these 2 points. What we want to do is, we can coincide these 2 points. Just click on this coincident and you can see it has coincided. Here, just click on this to close the dialog box. Now, does it look like a rectangle? Of course not. Let us give some other types of constraint to just get a feel of a rectangle. So first type of constraint that we are going to give is, I'll select this line and I'll make it horizontal. You can see. Let us select this line and I'll make it vertical. Just click on this. Now let us select this line and use the Control key for multiple selection. Select this line. Both of this line will make it parallel. You can see. Now let us click on this line and this line. You can see. Both of this line we can make perpendicular. So with this, I think we are able to see a rectangle, but we have not given any dimensions. If I move this line, you can see. If I move this point, of course it doesn't move because it has constraint. You can see. So let us give the dimensions. For giving dimension, we have the dimensional constraint. We find it here. If you click on this drop down menu, here we have various types of dimensional methods. We can give horizontal dimension, vertical dimension, and so on. I'll take smart dimension. By taking smart dimension, I can select this line and you can see I'm able to give a length. This length is in meters. That means we have to change the unit because I want to work in mm. What I want to do is I want to create a 100 into 50 rectangle. Press on the escape key to exit from the command. Now you can click here and immediately you can change your unit. Already I have told you how to change the units in previous lectures. Here I'll just select this millimeter, gram and second. mmgs. Click on this mmgs and of course we have exited from the sketch because the unit has changed. I'll just click on this line and double click on it. You can see the unit has changed. This dimension I'll just double click and I can change it to 100. Now let us give a dimension to this line. Use the smart dimension again and select this line. Here I'll give it as 50. Click on enter. Press on the escape key to exit from the commands. And you can see we have generated a 100 into 50 rectangle. But is it constrained? I'll just hold this line and move. Of course not. If you want to constrain this completely, then we have to give the relation of this rectangle with the references of SolidWorks. In SolidWorks, we have the reference here. This is the y-axis and this is the x-axis. And this is the origin. So with respect to this origin and the x and the y-axis, we have to give a relation. You can find here there is something called underdefined, which means that we have not defined the sketch completely. That is, it lacks some constraints, or in other words, it is under constrained. So to make it completely constrained and fully defined here, we have to give the relation with this coordinate system. So what we can do is, I can take smart dimension again. I'll select this line and you can see I can select this origin point. We can give a dimension to it. Maybe I'll give some 25. As soon as I give that, here the color is changing. These two have become black and these two lines have stayed blue. Press on the escape key. Now if I move this line, you can see it doesn't move. Press and keep the left mouse button and move the mouse. But if I click on this line and move, of course it moves because along vertical we have given a dimension and constrained these two lines. Along horizontal also we should give a dimension. So let us give a dimension. Let me keep it in the center and I'll give a dimension from this line to this point. This dimension, let us give some 50. You can see this rectangle is completely constrained, indicated by a comment here, fully defined, which means the rectangle is completely constrained. Don't worry, this is a very elementary stage for you to understand constraining. As we progress through the course, we will be completely using this sketch because, as I have told you in the last lecture, a sketch is the foundation for building any solid model. So, if you want to make a solid model or surface model, any type of model you want to make, you have to create a sketch. So, we are going to practice sketch extensively throughout this course. In the next lecture, we are going to see an example number 1, the very first example. And by using that example, we are going to explore more options of this constraining. And while doing that example, we will understand more about constraining. I'll see you in the next lecture. In this lecture, we are going to create the very first example of this course, that is example 1. This is the drawing that we have to create. We have to create a completely constrained geometry with these dimensions. Let us start. This is a new file in SolidWorks and I'll go to Sketch. Click on the sketch icon. I'll select this front plane. Now I am on a 2D plane. Let us select this line tool and create a rough sketch resembling the sketch that we want to create. Let us see it again. Here, this is the shape that we have to create. Let us create a rough sketch. Let me select here and maybe I'll select somewhere here and here. You have to prevent these lines that is getting formed. It will create unnecessary constraints. Before creating this, let me tell you something about creating automatic vertical and horizontal lines. It will be very useful while creating this sketch. Let me create the rectangle again which we have created in the last lecture. That is 100 into 50 rectangle. I will not completely constrain it. I just want to show you how to create horizontal and vertical lines automatically. I'll click here and as you move, you can see the line is getting locked in a horizontal position. The angle is showing 180 degrees and there is also a horizontal constraint symbol. When I click, you can see automatic horizontal constraint is getting created. When I move up, you can see at a particular position the line is getting locked. This is the vertical constraint which is going to be applied to the line that is getting created. When I move here, you can see I can create a horizontal constraint to this line. Again I'll move here and join. So the horizontal and vertical constraints are getting automatically created. So this is very useful. Let me just delete these 4 lines. I'll select by using a window. You just have to click here, press and keep the mouse left button and move to create a rectangle. Move the mouse and I'll release the button here. You can see it is getting selected. Now just use the delete key on the keyboard to delete the objects. Now let us create our rough sketch. Let me create it in the first quadrant, which is here, because this is the axis and this is the first quadrant. Let me select line here and you can see we are working in meters, but I want to work in mm. So I can go here and select millimeters, mmgs. Now I'll take line tool. It has exited the sketch, so I'll just press on the escape key and click on sketch. I'll select this front plane. Now we are again inside the sketcher workbench. Let us select this line tool and as I told you, I'll be working in this first quadrant. Let me select a point here and move down. You can see it is getting locked here. We have created a vertical line. Next, I'll create a horizontal line, another vertical line, a horizontal line, another vertical line, and continuously you can create the lines. You can snap this point or I can click here and I can join. You can see this is snapping. Click here, press on the escape key. If you have a closed geometry, then you will get this inside region as shaded. So this will indicate that your geometry is completely closed. If you don't want that, you can also deactivate this shaded sketch contours. If you just click it on, then it will be shaded. Let it be shaded for now. If you have some critical geometries, then you can switch this off. Now, the very first constraint I'll give is horizontal to this line. So, let me select this line and I'll make it horizontal. Now, let us give the dimensions. Before giving dimensions, let us see the drawing. Here, this is 50 mm, this is 100 mm. If you come here, this line and this line are in a single level, that is, you can coincide this line and this line. And if you see here, this line is 20, this line is also 20, this line is 20, this is also 20, and the entire thing is 100. That means this equal to this equal to this equal to this, and it is also equal to this line. So we can give a equality relation between these lines. Even this is 25 and this is also 25 because these two are in the same level. So we can coincide these two lines, or we can also make these two lines equal. And this is 12.5. Let us give the dimensions and the geometrical constraints. Let us take the geometrical constraints first. So this line, use the control key for multiple selection, and this line. These two lines will keep it collinear. You can see both of these lines are collinear. Even this line, and use the control button for multiple selection. These two lines we have selected, we can make it collinear. This line and this line, even this line and this line, all these four lines will make them equal. You can see there is an equal relationship here. Click on equal, and all these four lines have been converted into same length, except this line, because we have not used this line for creating equal constraint. I can just select this line and move. You can see we are able to move it, and when I move it, all these four lines are maintaining their equal lengths. Now let us give the dimensions. I'll take the geometrical constraint, which is the smart dimension. Click on this. I'll select this line and will give 100 dimension. You can see 100 length has been given. Again, I'll take this line and give a dimension of 50. Then I'll take this line, give a dimension of 20. I'll take this line, I'll give this dimension as 25. Then we are left out with only one dimension, which is this dimension. It is of 12.5. Press on the escape key to exit from the command. Now you can see we have given all the geometrical constraints and the dimensional constraint, but still the colors of these lines are blue, and here if you see, it is showing underdefined. So what it means is it is not completely constrained. Let me just select this line and move. So what it means is we have not given the reference relationship with this coordinate system. So I can just take this line, use the control button on the keyboard and select this point. Between these two, I can give coincidence. You can see. Now again, before you give anything else, you can see by giving that constraint, this line is black and all the horizontal lines are black. Only the vertical lines are blue because it requires another constraint. And that constraint is relationship between this coordinate system and the direction along this, because if you move this, only the object moves along this horizontal dimension. I'll take this line, use the control key on the keyboard and select this point. You can see we'll use the coincide constraint. And you can see the entire object is completely constrained. If you see in the bottom here, it is written fully defined, which indicates the object is completely constrained. So we have created a completely constrained example 1. In the next lecture, we are going to see how to remove a constraint and various colors during constraining. I'll see you in the next lecture. In the last lecture, we have seen how to create example 1 geometry, which is this. In this lecture, we are going to see how to remove a constraint and various colors that you encounter during constraining. During constraining, there are few types of constraint conditions that you have to avoid. The very first thing is over constraining, and second is inconsistent constraints. We'll see these two a bit later. First, we need to know how to remove a constraint. Let us use this example 1 and learn how to remove a constraint. Suppose I want to remove this 100. Just select this dimension and use the delete key on the keyboard. And it is getting removed. By removing that, one of the lines, that is this top line, has become blue. I'll just move this and you can see what is happening is this line is not having a length. This length was controlled by this 100 mm. So what we can do is either I can use equal relationship between this line and this line, or I can give a dimension to it, which is 20. Just select and give a dimension 20. You can see again it is converted into black. So this is how you can delete a dimensional constraint. Now suppose what I want is I want to delete this horizontal constraint. Just select this constraint. You can see I selected this constraint. This is converted into blue instead of green, and I will delete. Even remove this vertical constraint. Select and delete. Let me delete this 20. You can see. So this is how you can remove a constraint. Now let us see the various colors that you can encounter during constraining. Already we have seen a geometry which is not constrained is having a blue color, and a geometry which is completely constrained is having a black color. Next, another constraint will come. Suppose I want to make this line horizontal. I'll just select it and I'll select horizontal. You can see some red colors have appeared. What it means is this is a inconsistent geometry. That is, here we have given a coincident relationship between this line and this line. So both of them are in a single level. When we are saying that this is a horizontal line, that means we are changing the orientation of this line. That is not possible. So it indicates that this is an inconsistent geometry. Press on the escape key and I will simply delete this constraint. Select this and delete. And now you can see the colors have gone. Similarly, suppose I will give a dimension to this line. Maybe I'll take smart dimensioning and I'll give a dimension to this line. Maybe I'll give some 15. Press on the escape key to exit from the command. Here, this line, we have made it equal with this line. Now again what I will say, this line I'll make it equal with, use the control key for multiple selection, this line. So these two lines I will make it equal. When I give a equal constraint, again that red symbol will come. This is called over constraining, which means already I have given equality between this line and this line. Again I am saying that this is equal to this, but 20 is not equal to this 15. So this is not possible. It is a over constraint that I am giving to this line. Over constraining is giving more than the required constraints. Don't worry, as we progress through the course, you will have a good command on all these colors and how to solve this type of geometry. If you want to solve this automatically, in SolidWorks there is a beautiful system. Just click on this overdefined and you'll get this sketch expert, where you can click on this diagnose and it will give you solutions. It has given you 6 solutions and it is also showing you what it can do to solve this case. This is the number 1 of the 6 solution. This is the second solution, third solution, fourth solution, fifth solution and sixth solution. So which is that you want? You can see. So what it is saying in this solution is, it wants to keep the equal relationship between this line and this line. It wants to cut this 15 dimension and automatically it will become 20. Click on accept and you can see it has solved. Click on this OK and you have a completely solved geometry. So in this lecture we have seen how to remove a constraint, and also we have seen what is under constraint geometry, and we have seen the colors when we encounter a constraint geometry, a under constraint geometry, a over constraint geometry and a inconsistent geometry. In the next lecture we are going to see how to trim entities.